Hi, my name is Michael Daniel. I am an Energy Corps member at the National Center for Appropriate Technology. Generally, appropriate technologies are smaller scale technologies that are ecologically and socially benign, affordable, and often powered by renewable energy. Today I want to talk about a type of appropriate technology used to create a soil amendment called biochar. Biochar is a carbon-like material that is very porous in structure, and it serves several different functions in the soil. It helps aerate the soil, break up clay, absorb water, absorb nutrients, and create a luxurious home for healthy microorganisms. So the way we're going to create biochar is through a biochar retort kiln, and in our case, using a rocket stove. Ultimately, the rocket stove is going to help us reach higher temperatures using less fuel. So when thinking about appropriate technology, we think about, using materials that are readily available and very affordable. In our case, I'm going to go through and show you what type of materials we've used. First of all, you'll need to pour a level concrete slab. By the end of this, your kiln will be fairly tall, and you'll need a level surface to work with. You'll need 70 fire bricks, 2 55-gallon drums, perlite insulation. You'll need 2 pieces of angle iron, high refractory cement, and you will also need a retort, an oxygen limited chamber. In our case, we've used a smaller 30-gallon drum with an attached lid. You will also need an insulating blanket, fiberglass insulating blanket or cow wool, and you will also need plumber's tape to hold that insulation on. So rocket stoves have several different applications. People use rocket stoves to cook, and different designs to heat homes in what's considered a rocket mass heater. Ultimately, the rocket stove is going to allow us to reach extremely high temperatures using very little fuel, and it's a very efficient design. This design is based on Ianto Evans' design in his book, Rocket Mass Heaters, super efficient wood stoves that you can build. So we've basically taken that design and altered it, and it's been very effective. So I want to explain how to build the rocket stove itself. First of all, you need to pour a level concrete slab at the bottom, because by the end of this, your kiln's going to be pretty tall, and you need a nice level surface to work with. As I mentioned before, you need 70 fire bricks, and these fire bricks, you're going to lay down one portion that's going to act as the very bottom of the rocket stove. You can't see it here, but the rocket stove features a burn chamber that is the exact same diameter all the way through. So the diameter here inside the intake is the same diameter all the way through and up the heat riser. This is the top portion of the heat riser, and it's the same diameter as this. And it's essentially this, but higher. So you build that rocket stove itself, and then you're going to want to further insulate the heat riser just to further add to the efficiency. So in order to do that, again, we've used a 55-gallon drum. To begin with, you need to cut out the very bottom portion of the 55-gallon drum and the top portion, so you're just left with the cylindrical wall. In which case, because it's hollow on the bottom and the top, it can fit nice and snug over the heat riser itself. Also, you will need to cut a pattern, and I did this with cardboard. You just trace it onto the metal itself and use a sawzall to cut out a pattern for it to fit nice and snug over this portion of the rocket stove. Once this bottom 55-gallon drum fits nice and snug over the heat riser, you can then add perlite insulation to further add to the efficiency of the heat riser. Once that's done, nothing's mortared here, nothing's tied down. It's just nice and snug over everything and nice and flush with the bottom of the concrete, and in which case the space between the heat riser itself and the cylindrical portion of the wall of the 55-gallon drum can be filled in with perlite. So biochar is created through a process called pyrolysis. Pyrolysis is the decomposition of organic material involving very high temperatures and an environment with limited to no oxygen. The chamber in which pyrolysis is going to take place is called the retort. In our case, we've used a 30-gallon drum with an attached lid as our retort. So this is the oxygen-limited chamber in which biomass is loaded to be charred. What you want to use for your biomass is something very heavily carbon-based. Biochar itself is essentially black carbon is what you're left with. So you want to use something with a very high carbon content. In our case, we've used thin pieces of kindling, and this is going to be what's going to be charred. So once your biomass is loaded inside the retort, you want to make sure the lid is nice and snug. But you also want to place, whenever this material begins to get hot, it is going to start letting off wood gases. And you need a place for those wood gases to escape. So as you can see, this lid is nice and snug on here, but I still need a place for the gases to escape. So in our case, we've drilled 24 quarter-inch holes in this portion of the lid. And this allows the the wood gas to escape. If you didn't have a place for the wood gas to escape, this barrel would build up pressure and would probably bulge and would damage the barrel. So when loading this retort onto the stove itself, it's elevated on 2 pieces of angle iron. So when the rocket stove is operating, the hottest portion of this is going to be right here at the very top of the heat riser. The rocket stove, this is going to be the portion where you load your firewood. If operating properly, the fire will be burning horizontally and all the heat will travel in one direction. And that's up at the top of this heat riser. When operating, the hottest portion of this kiln is going to be right here on top of the heat riser itself. And this is where we want to place the oxygen limiter retort. We don't want to place it right on top of the heat riser to block oxygen. We want to elevate it on what I have here is 2 pieces of angle iron. So these pieces of angle iron sit right on top of the heat riser, and the retort sits right on top of that. Also, when putting the retort on, you want the place you've created for your wood gases to escape to be at that hot portion to hopefully flare off. So in our case, we're going to load this retort upside down on top of the kiln. So at this point, your biomass is ready to go, your ash pit's cleaned out, and you're ready to burn, but we need to add the second 55-gallon drum around the 30-gallon drum to help contain some of the heat. Okay, so now that we have the retort loaded, the biomass is loaded and the retort is in place. We then add the upper 55-gallon barrel with the fiberglass insulation around it on top of here so it's nice and flush. So this barrel features an insulating blanket around it, and this helps keep heat in instead of radiating to the outside, especially on cold days. So this is fiberglass insulation, and the fiberglass insulation is fine up until 1300 degrees Fahrenheit, and that's its melting point. So it's fine to use, but the wrapping on this may have been hotter than it gets hotter than it was designed to originally. So ideally, for this wrapper, you would use cow wool, and that's Kawool, cow wool. Also, we have an aluminum alloy chimney, and this is something that was found at the scrap yard. But if you want something that's going to be a little bit more permanent than that, even you might want to go with a triple wall insulated chimney, maybe made of steel. But this works for our case, and it's worked so far. So at this point, this is going to help contain the heat. Once the heat comes from at the top of the heat riser and around the retort, this is going to be used to help keep some of that heat in. So this 55-gallon barrel actually has the bottom portion of it completely cut out, and that's going to fit nice and flush with the bottom 55-gallon drum. So I'll do that right now. And at this portion, you might need to get a friend to help you load it. but it's easy enough to do by yourself as well. So as you can see, the 55-gallon drums have the same diameter, fits nice and flush, there's no cracks. The only openings you have at this point is the intake and the top of the stack. And it's important to, your stack, you want it to be about the same diameter as your intake. Reason being, it's a closed system and it's all the same diameter all the way through here, and heat travels, basically when heat travels up the heat riser, up the barrel, and out the chimney, as heat rises, it kind of pulls in from the intake. So when operating, like I said before, when the fire is operating, the fire will be burning horizontally in this bottom chamber here. And the heat will all be traveling one direction. And the retort is going to take the brunt of most of that heat. So at this point, we're ready to fire it up. The ash pit's cleaned out, the retort's loaded, and it's good to go. So some rocket stoves are considered an L tube, and some rocket stoves are considered a J tube. This rocket stove is considered a J tube. And one reason a J tube is beneficial over an L tube is that it can actually self-feed itself. And the way it does that is, it's literally shaped like a capital J. It's literally shaped like a capital J through here. You got we've used chopped up pallet wood. And the way this works is, you load it vertically in this burn chamber. This is where your fire is going to take place. Because it's gravity fed, it will actually self-feed itself. Once operating, the fire is going to be burning just the very bottom tip of the wood itself. So it's okay for the wood to hang out like this. So once it's all loaded up, you're ready to start a fire. And again, the more it burns at the bottom, and these pieces will just self-feed. So at this point, we're ready to start our fire. Most likely you will not need it because it's a very controlled burn and everything is contained. But just in case, it's good to have a water hose handy, just in case you get any wild embers. Okay, so at this point you're ready to start your fire. And as an accelerant, I used 99% isopropyl alcohol and a propane torch. And the propane torch actually helps because it helps get the draft going the correct direction. At this point, air should be pulled in here once the fire starts to get going, but if your fire starts to burn out here vertically, it's not burning properly. If you see any fire burning out this way, just give it a quick blow, and then the fire should start burning horizontally. So you're ready to light it up at this point. Just pour a little bit of alcohol on. You don't need much. And then start your propane torch here. So this is the key as to why a rocket stove is very efficient. All the fuel we're using is not being wasted. You could build a regular campfire, but in which case your fire's not contained. All the heat and all the flames are kind of traveling every which way. Well, because we've created this chamber and this draft, which is caused by the stack effect, the flames are all burning horizontally into the chamber, as well as all the heat is all traveling in the same direction, thus being super efficient. Again, we're using less fuel and creating higher temperatures this way. And you can put your hand here and not be burned, but if you put your hand on top of where the heat riser is, it would be extremely hot, way too hot to touch. So again, this is the reason why a rocket stove is super efficient. So at this point, the rocket stove retort kiln is operating like it should. All the heat's traveling in one direction. Again, this is where your fire started. And again, it's traveling through this chamber, which is the same diameter as this, all the way up through the heat riser. So the heat and the flames are all traveling one direction. Again, the heat riser is contained inside this 55-gallon barrel. Our retort is right about here. And this upper barrel is doing its job by keeping the heat contained around that retort. So the insulating blanket and the barrel itself is keeping heat contained around the 30-gallon barrel retort. that we've created, and at this point material has started to char. At this point, once it gets hot enough, material will start to break down and decompose, and wood gases should escape at the bottom and hopefully flare off inside this barrel. So one good thing about rocket mass heaters and rocket stoves is they're supposed to burn very clean, but in our case you might get a little bit of smoke at the top, and that's because it hasn't got hot enough inside this chamber yet to flare off those wood gases. So you will see a little bit of this, but once it gets hot enough, those wood gases should flare off inside the chamber, and you should see very minimal smoke out of the top of the stack. So at this point we're almost ready for to extinguish the system. You'll still have hot embers in here just to illustrate how hot it'll be. You know, just a couple seconds and a piece of wood will catch fire. But one thing you want to avoid doing whenever you put out the system is you want to make sure that you don't spray water in here. The fire bricks themselves are very strong as far as their ability to take really high temperatures, but they're also very brittle. And so if you spray water in them, then they absorb that water, and then once they get hot again, that water can turn into steam and can actually cause the bricks to crack. So the best way I have found to extinguish this is to take 2 more fire bricks and just deprive the whole system of oxygen. And just put your bricks over so that no air can be in the intake, and that'll close it off. And then you'll do the same thing on top of the heat riser once it cools down a bit. So at this point we've taken the upper 55-gallon barrel off, we've taken the 30-gallon retort off, we've covered up the air intake, but it's still extremely hot right here. So again, to kind of close off the system without spraying it with water, just add 2 more fire bricks to the top here so that you've closed off the system. And so at this point, your biomass should have charred all the way through if it worked properly. But the retort is still extremely hot. Again, it was deprived of oxygen, so if you were to open this right now for an extended period of time and allow air to get to the biomass, it will most likely combust, and you do not want that. So you can do one of 2 things at this point. You can wait for the biomass to cool down and then pulverize it, or you can spray water and pulverize the material, and spray the water before you pulverize it to kind of cool it down. But this is what you'll end up with. Your material should turn into something like this. And this is very brittle and ready to be pulverized. The reason why you want to pulverize the material is because biochar is very porous, and that's what is its main attribute. So the pores have several different functions, like I talked about before. It aerates the soil, it breaks up clay, absorbs water, absorbs nutrients, and creates kind of a luxurious home for those microorganisms. So to be most effective, you want the biochar to be crushed up, and you want to increase the surface area and expose as many of those pores as possible. So you want to take this material and crush it up and pulverize it. And so by the end of crushing it up, you're going to end up with something like this. Should be a very dusty material. And at this point, this char is ready to be added to the soil. Okay, so if you were to crush the biochar when it was dry, it's going to be very dusty. So to sort of kill 2 birds with 1 stone, you can use water to cool it down, and also by moistening the material, it's a little bit less dusty when you go to pulverize it. So I'm going to go ahead and do that now. Once you've wet it down, again, it's very brittle material. And this is what it looks like. At this point, it's ready to be crushed up. And as you can see, everything charred all the way through. And it's very easy to crush by hand. Larger amounts, you may want to use a compost shredder or hammer mill, but for a garden size crushing it by hand should be sufficient enough. Thank you for watching this video on small-scale biochar production using a rocket stove retort kiln.